So you're on your way to becoming an automation engineer. You're learning how to build machines that literally run our world. But, building them is really only half the battle. The real game changer, the thing that separates the good from the great, is making those machines think. Today, we are diving deep into optimization. This is the skill that turns a simple bot into an absolute genius. I want you to picture this for a second. You've designed a factory with 100 robotic arms. They are all moving, all working. They're busy for sure. But are they brilliant? Are they actually working together in perfect harmony? Or are they just kind of getting in each other's way? This right here is the core challenge you're going to face. It's not just about making robots move. It's about conducting a symphony of pure efficiency. Because, let's be honest, without that intelligent coordination, what do you really have? Well, you've got wasted energy, you've got machines just sitting around idle waiting for parts, you get these massive production bottlenecks, and a whole lot of really, really expensive equipment that's not even close to living up to its potential. The true value isn't in the robot itself, it's in how intelligently it works with everything else. So how do we fix all this chaos? How do we bring order to the factory floor? This is exactly where optimization comes into play. It is the key that unlocks peak performance, turning a system that just functions into one that absolutely excels. Okay, so what is it really? At its heart, optimization is just a structured way to make the best possible choice. You start with all the things your system could do. Those are your feasible alternatives. Then you apply your real-world limits. We call those constraints. Stuff like your budget, your deadlines, your energy usage. And from all those possibilities, you find that one single best path forward. And here's a really simple way to think about it. Mechanization basically asks, can we get a machine to do this? It's about replacing a person with a robot. But optimization? Optimization asks a much deeper question. What is the absolute best, smartest, most efficient way to get this done? It's not just about doing the work, it's about doing the work intelligently. You can almost think of optimization as the central nervous system for your whole operation. It's the brain, the decision-making core that takes a bunch of separate machines and turns them into a single, intelligent organism. One that's not just productive, but truly, deeply efficient. All right, enough with the theory. Let's get our hands dirty. We're heading out onto the factory floor to see how this stuff actually works in the real world. Pay attention, because these are the exact kinds of problems you are going to be hired to solve. So let's take a single robotic arm. Maybe it's welding a car chassis or painting a door panel. Every single millimeter of unnecessary movement, every tiny hesitation, every angle that's just a little bit off, it all adds up. And when you multiply that by thousands of cycles a day, that tiny wasted motion becomes a massive drain on time, energy, and, you guessed it, money. So how do you fix it? Well, we optimize it. First, an algorithm maps out every conceivable path that robot arm could possibly take. Then we start layering in the real-world constraints, things like other machines it needs to avoid or speed limits to make sure the weld is perfect. And finally, the system crunches the numbers and calculates the one single path that is the shortest, the safest, and the most energy efficient. And the results? They are immediate, and you can totally measure them. You're using less power, which is great. The movements are way more precise, which means higher quality products. There's less wear and tear on the gears and motors, so the equipment lasts longer. And, this is the big one, you shave precious seconds off the cycle time. That means more cars, more products, more everything per hour. Okay, but it gets even more complex. Let's zoom out from that one robot to the entire production line. Now you've got dozens of different jobs that need to be done, and a whole bunch of different machines that can do them. The new puzzle is a big one. Which job goes to which machine and in what exact order? Get this wrong, and you get pure chaos. Expensive machines are just sitting there, doing nothing, creating bottlenecks while work just piles up somewhere else. But with an optimized schedule, you get this beautiful, smooth workflow. You achieve what engineers call a minimized make span. That's just a fancy term for the shortest possible time to get everything done. The result? You hit your deadlines every single time. Now, this same kind of thinking goes way beyond the factory floor. Let's take a walk over to the modern warehouse and see how optimization is completely revolutionizing logistics. See, every warehouse manager is fighting this constant battle. If you keep too much stuff on the shelves, your money is just tied up and you're paying a fortune for storage space. But if you keep too little, you risk running out, stockouts, which means you're losing sales and making customers really unhappy. It is a classic high-stakes balancing act. The solution lies in using these incredible optimization models to predict exactly what people will want and then manage the stock inside these things called automated storage and retrieval systems, or ASRS for short. These systems aren't just giant shelves, they use powerful algorithms to make sure you have exactly the right amount of product on hand at all times. No more, no less. And you can see how this mindset touches every single part of logistics. It's used to design the most efficient layouts for conveyor belts, to plot the fastest possible routes for those little automated guided vehicles, the AGVs zipping around the floor, and even to schedule high-energy tasks like battery charging for when electricity is cheapest. So let's bring all this home. We've seen optimization with robots on production lines and inside massive warehouses. But why is this so incredibly critical for your career as an engineer? Because these goals on the screen, these are the metrics that are going to define your success. Companies aren't hiring you just to make things work. They're hiring you to make them work better, faster, and cheaper. They want higher output, minimal waste, practically zero downtime, and maximum cost effectiveness. Optimization is the powerful tool you're going to use to deliver on every single one of those goals. And really, when you get down to it, your value as a future engineer isn't going to be in just connecting wires or programming one robot. It's going to be in your ability to see the entire system, to understand all its moving parts, and to apply these principles to make the whole thing smarter. You're not just a builder, you are the intelligence layer. The challenges out there are absolutely massive. I'm talking about creating sustainable manufacturing, building hyper-efficient global supply chains. The list goes on. The mathematical tools, the insane computing power, it's all right here, ready for you. So the only real question left is, what complex, fascinating problem are you going to solve first?